This is the podcast of KC Digital Storyteller, the digital historian of Silicon Valley, the creator of the documentary A Place at the Table that tells the history of some of the African American pioneers of Silicon Valley, available on Vimeo.com on demand. KC Digital Storyteller podcast will consist of technologists, engineers, and professionals in a variety of fields, as well as individuals with entrepreneurial pursuits from the past and present. Today, my guest is Chris Cotton, a high-level technologist currently working with Google. Chris has worked as a software developer for companies in Hong Kong, Singapore, United Kingdom, and the United States. He has been a CTO, software developer, and senior DevOps engineer for hundreds of clients, and comes to talk with us today about his life and career. My documentary is about the pioneers that came to Silicon Valley that opened doors for guys like you. You are one of those guys. You were the next generation. What was the first company you worked with?
I was doing internships at HP initially, summer internships, which kind of helped me pay my way through college. And then I went from there to work for a bit in Africa and traveled all over Europe, and then worked on an internship in Africa. Came back to U.S., worked at HP for a number of years, back in the same group, in the Carl Snyder Lab, Ada compiler group. I was doing QA automation at HP, and I've been doing the same thing for one of my summers and then for a couple years, and started to get the itch to branch out a little bit, expand my skills, broaden my horizons, see what was out there in the big bad world. So I figured the best way to do that was to take a variety of positions, short-term, contract, and just kind of get a nice overview of the industry. I did a lot of QA automation. I did release engineering and automation for that. I did some development and just sort of further sharpening my programming skills. I did some sysadmin and operations. I did some setup, some network administration, and that sort of rounded out my IT and operations capacity, got me more intimately involved with hardware and load balancers and various things. And so just kind of learning how all the pieces fit together. You know, it's just kind of my nature. When I was a kid, I was the type of kid that would look at a radio and sort of marvel at it. And then next thing you know, my mom would come in the room and it'd be in pieces on the floor. Okay. I was just kind of curious because I just kind of wanted to see how it all fit together, you know, end to end. And so similar kind of thing with my career. I just kind of, you know, at one point I was sitting there typing away and bits were flying all over the earth. And I was like, how does this all work? So it was kind of interesting to play with the hardware and, you know, to get a certain level of mastery over the OS, and then another level of mastery over scripting languages, another level of mastery over programming languages, and just kind of see how it, you know, that's what made it fun for me. Is to kind of.
So did you start off as a software person, or when you were getting your education, was that your goal to be a software person? Because that was pretty early in the industry, and software was a mystery to a lot of people. So tell me how you got there.
Yeah, honestly, there were kids in my neighborhood, and their dads would come home in like nice cars, and we'd be playing football, and I'd say to my friend, "Man, what does your dad do again?" And they'd be like, "Oh, well, he's a software engineer." And I'd be like, "Oh, okay, that looks pretty cool. And what does that mean?" And so I would ask his dad what that meant, and they would show me the stuff they worked on, and they'd show me code and things like that. And I was like, okay, so this was sort of right after high school, and then I wasn't really sure what I wanted to do. So in order to try to figure that out, I went to community college for a while and took some programming classes, and thought it was fun, but I liked it somewhat, but I can't say that it was something that I wanted to do all day, every day. I was fascinated by it, but I kind of wanted to understand all the pieces, like, going back to my analogy about taking apart a radio. I wanted to take apart every aspect of the engineer's life and see how all the pieces fit together, as opposed to go really, really super deep on any one area at that point in my growth and development. So it was just more of a curious thing, and that's what kept me interested in that's what I thought was fascinating and liberating about engineering, as opposed to a lot of other types of professions, is that there was all these layers to it, and it was constantly changing. Underlying all that change, there was some fundamentals that just were perennial, and so I was like, okay, this is fascinating. So the days went by fast, the years went by fast, and it was fun, and I was very satisfied. And really couldn't say I was bored or anything. So that's kind of how it started. I was a philosophy major, and I had a sort of a CS specialization, like a minor. In my entire academic life was writing papers about symbolic logic or arguing some philosophical principle, making sure that my arguments were sound and logically consistent, or writing programs, which is kind of the same thing, but providing instructions to machines with logically consistent bits of code. So similar, but someone from the outside would think they were very different.
So
they're actually very similar.
Let me ask you this. You've worked all over Hong Kong, Singapore, United Kingdom, Africa. What country was the most helpful to your career? Where did you learn the most? What country would you say?
Found the actual experience of living in other countries quite exhilarating and interesting and very stimulating. To be perfectly honest, from a career standpoint, the USA has been number one, and that still holds true today. I think it's remarkable kind of how far ahead we are on so many levels. I think only recently have we begun to possibly be leapfrogged in very specific areas. Specifically, I think like stem cell research or cyber bionetic interface therein. So, there's certain countries like Singapore comes to mind, Hong Kong comes to mind, maybe parts of Shenzhen in China. The other thing, I think robotics, maybe we might have some formidable competition finally, again from Asia. To some degree, I think Japan, like Hong Kong, might be attempting to leapfrog us in the very specific area of blockchain and Bitcoin technology. But other than that, the U.S. tech market is the place to be. There's nothing like it, and it's nearly impossible to replicate anywhere in the world, just in terms of the variety and just the draw, the confluence of investors and entrepreneurs and free thinkers and highly skilled engineering talent and creativity and willingness to sort of push the envelope. I think the U.S. is far above all the other places I've worked, is leading the pack. Specifically, I think the West Coast, apart from fintech, the West Coast is kind of ahead of the East Coast. When I was in Hong Kong, that was the last place I really worked. I'd have to say they were a good year and a half, 2 years behind. I think maybe that gap is probably close to about 8 months. But 8 months in Silicon Valley is a long time. I think a lot of these places too, one thing I noticed is that they just lacked the infrastructure. I think that's going to level out because with the introduction of the cloud is going to equalize a lot of this. But the other factor that's really key is that we are not as risk averse. And I think a lot of the other players that are in the number 2, number 3 spot, China, Japan, they're far more risk averse just culturally. And so I think it's harder for them to innovate faster. Their advantage is that there's a lot of smart people there, and they're getting smarter every day. And so it's going to be interesting to see. I might end up back there for some projects, but for now, I think I'm going to focus on the U.S. because especially in my particular field that I've chosen to focus in the last couple of years, DevOps seems to be this is the place for sort of cutting edge DevOps.
So DevOps is that does that mean that you manage IT infrastructure, or explain to me what DevOps is?
Okay, so the term DevOps is sort of a compound word. It's development and operations. So it's someone who understands operations and network administration, but they can also code. So the reason why that's significant is that given the pace and the scale of products and services on the internet, and given the introduction and ubiquity of the internet in our lifetime, this of building and deploying and iterating on the release of products dramatically transforming. And so back in the old days, you would have these large machine rooms, and you would have considerable capital investment on hardware that you would then keep on premises, and then you would then connect those things to the internet. Many of the machines you would connect to the intranet, and then only a few you would connect to the external world, the internet. And then you would go about building your applications in a way that the entire application was sitting on one or two machines. These two machines would talk to each other, and you had names for them, and then people would access those machines via the internet. And then, when the lines got saturated, you would wheel in a third machine and you would make a copy of the app and stick it on a third machine. And this was a major process. A lot of times happened at 3 or 4 in the morning, and you'd end up staying up all night, eating pizza and moving machines around. And it was nasty. That became unwieldy, this sort of manual process. So the coding of the application, you've got the testing of the application, you've got the building of the application, and then you've got the deployment of the application. And traditionally, you could do a lot of these by hand, but it was very repetitive and very error prone. It got to the point where, hey, I know you're a sysadmin, but you should learn how to write some scripts or something, because then what happens is you don't have to keep doing this process manually. You don't have to, when we build the product and we assemble all the pieces and then we test it, we want to be able to automate as much of that as possible, because that's where the efficiencies are. That's what makes it cost effective, and that's what makes it accurately repeatable, right? People who understood the QA part of it, or the build part of it, or the deploy part of it, and the scalability part of it, scaling the app up and down when traffic got overwhelming. These were internet apps, right? This is, you're moving out of desktop apps and into internet apps. So when internet apps started happening, when you could do all that and you could write code that could make that repeatable, you became a valuable commodity, and you were never without work. So, and you were having the most fun in the room. Yeah. Because I had a background in test automation, which was, I could simulate thousands of users in one go with one program, as opposed to going to a college campus and hiring 1,000 actual people to bang on our code. We could actually simulate 1,000 actual people using our code with a couple of 100 lines of script. So because I was already familiar with that, I was a good candidate for this. So it was not a foreign concept to me to figure out how to automate the build part, and then figure out how to automate the deploy part, and then figure out how to automate the monitoring part, and then figure out how to automate the release part, and then figure out how to automate the rollback and the redeploy and so on. So there's this whole cycle. Meanwhile, while I was figuring this out over in San Francisco at my little company, me and my team, there were hundreds of teams up and down the street from us figuring out the same stuff and all sort of chatting online. And we all sort of kept reinventing the wheel. And then when everybody had solved all the hard problems, they shared it with each other and said, hey, listen, remember that hard problem that we were trying to solve? Well, we've got the answer, and we're going to put it in the form of a tool that we're going to open source, and everybody can use it, and we can all share it. So this is the sort of spirit of open source that sprung up in Silicon Valley during the early days of the internet, and it sort of caught on like wildfire. And it was a very liberating process to be able to say, hey, that problem we've been working on? Well, now they got this tool, and it's free, and everybody can use it. And not only that, we can extend it, we can contribute to it, we can put our own 2 cents in because they don't have all the answers. There might be some bugs or whatever. So it created this collaborative environment, which then sort of just picked up a lot of steam, and it was really fun. So a lot of open source tools started being built that would solve the problems that arose during build and deploy. And,
well, now you're talking about the open
operations.
source and how easy it was to share all this information back in the day. How would you go about solving the same kind of problem today in organizations, or a business problem? I'm assuming that it's not as open and freewheeling as it was, say, 10, 15 years ago with intellectual property laws and all this other stuff.
No, I have to disagree. As a matter of fact, if you just look at the amount of contributions onto things like GitHub, and if you just do a Google search for a number of open source projects that are out there in the world, I think the number just continues.
So there's a place where people can go and learn this open source information that's out there?
Right. So there are public repositories like Bitbucket, like GitHub. So let's say that you are tasked with, let's say you're tasked with building a game, right? And you want to create a game that is similar to, has all the basic elements and functionality of a game that you already know, but might be skinned differently, might have slightly different characters. Well, say you wanted to be a single person shooter, right? So you could type in single person shooter, action adventure, Unity 3, pick your gaming engine, template, let's say, GitHub, right? Hit return. There's hundreds of other people who started building this thing, got it to a certain state of readiness, and said, wow, this is cool. This would be a good foundation for somebody. Or this is a good exercise. Maybe they were preparing for a job interview, or they were just doing something at their company, and they said, hey, this is a cool little thing. I should share this. This would be a good use of this particular language, or this particular gaming engine, or these particular skins, or whatever. So then you could then theoretically go find that game, fork that repo, check it out like you would check out a library book, and build on top of it. And then you could call that your own. Hey, I started with this and I built on top of it. Or you could check it back in and say, hey, I made a contribution to your game. I want you to code review. It's called a PR request. Do a PR, and then they basically review your code and say, yeah, that looks like a good change. And then they would integrate that back into the source. Or you could take that version of the thing and do what they call the fork, and then build on top of that, and then check that into your repo as your own thing built on top of that thing. You would have to specify what sort of licensing you want. If you specified it as open source, if you specified it as freeware, then other people could use it in their projects, and you could be as liberal or as constricted as you want. You could have your repo be private, where nobody could see it, or you could have it be totally public, where anybody could see it, download it, play with it, modify it, do whatever they wanted to it. So the number of those things has only increased. And so that makes it easier that if you have some momentum and you kind of know what you're doing, it makes it easier now than ever for you to get up and running and started and doing something interesting.
You were listening to part 1 of the discussion with Chris Cotton and his path to becoming a DevOps engineer. Part 2 will air in 1 week. For more information on open source repositories, please go to aplaceatthetable.com/community, where I have a list of those sites. Rent the documentary, A Place at the Table, the story of the pioneers that preceded Chris and young men and women of color in Silicon Valley, opening doors for technologists like him to thrive. You can rent the documentary for 3 days and show it to classes or individuals. Go to vimeo.com/on-demand/ and key in all one word, A Place at the Table STEM. It's a great documentary for Black History Month. Until next week, thank you for listening.